Okay, we're going to start off. I have some notes for today, that stuff we're going to cover, and I hope there's enough time. But we're going to start cover constructor chaining. What I mean by that: polymorphism, class diagram, test cases, and Java dates. And do keep in mind, if we don't cover all of this in lecture, there should be materials online for you to review this in. So let's start out by writing some rules for constructors. All right, this is going back even to the first time we started talking about classes and objects. A constructor, is the code that runs when an object is created. So when you say student S equals new student, and then maybe you have something in parentheses, that's calling a constructor, and that will call the constructor that matches the number of arguments. So if I said student S equals new student, and I don't give any parameters there, this would match the constructor in student with no arguments. If I were to say student S1 equals new student Zellers, that would match the constructor that accepts one string. What's a constructor look like? Public, the name of the class. In this case, student. No return type. This might be the one that accepts a string as an argument. So you have the list of arguments. Then you have the body of it, which usually assigns attributes of the object, the value of arguments. So we'd probably have something like this. L name equals arg name. This is more or less a definition of a constructor. This is what happens. This is how we call constructors, how we define constructors. Let's get into the rules now. For all classes, if you don't define a constructor, don't define any constructors, compiler generates a no argument constructor. Remember back to our first lab where, well, no, that wouldn't be a good example. The first student lab that we did, or the first version of the pizza lab that we did. We didn't create any arguments or any functions with any number of arguments, but we were still able to do this. Student S equals new student, or pizza P equals new pizza. All right, why were we able to do that? Because if you don't define any constructors, the compiler generates one no argument constructor. If you define any constructor, the no argument constructor is not generated. And if you want a no argument constructor, you have to code it yourself. For example, maybe you know, I used to go to lunch at a place in Cleveland when I went to Cleveland State, and it's called Daryl's, I think. And they had a special for like, you know, personal pizza for like 89 cents. It was unbelievable. We were outraged when it went all the way up to 99 cents. But that was literally, I think, 8-inch pepperoni pizza. Now, they had other kinds of pizzas that they served too, but that was more or less their default pizza. All right, small with pepperoni. Their default pizza. So for their company, you could create maybe a no argument constructor that defaulted the pizza to small and with pepperoni. All right. In other cases, maybe there isn't a default, you know, but if there is defaults, you can set them in the no argument constructor. All right. So you can't have a no argument constructor if you have coded another constructor, but you have to write it yourself. It's not automatically generated. The generated one, all it does is allow you to create objects. You can have multiple constructors. The rule for that is can't have two where arguments match. In terms of the number of arguments and type. So if I define a student constructor that accepts a string, I cannot define another student constructor that accepts a string for the email, let's say. And the reason for that should be obvious. If you are able to define two constructors with the same arguments, the same number and type of arguments, if you could define that, then when you called that, the Java runtime engine wouldn't know which constructor to call. Do I call this one that accepts a string or this one that accepts a string? So that's how you tell what constructor gets called based on the number and type of arguments. I can use this. Would this be a pronoun? I don't know. I could use this to call another constructor the same class. Let me show you what I mean by that. Yeah, go ahead. Whatever is. Here's what I mean by this. If I call constructor with one string argument, this constructor gets called. But notice what it does. It sets the size of the pizza and calls the constructor that accepts two arguments and passes on the argument for the size and defaults the kind of pizza to thin crust. Finally, this one calls the three argument constructor, the one that accepts two sizes and a Boolean for whether it has pepperoni or not. I can do that in any class. If I call a constructor, I could call another constructor. And that simply prevents you from repeating code. Now notice that these call the set methods. I think in previous examples, I just said something like size, arg size. Well, that was okay when we were first learning this. But now that have advanced a little bit, we're actually going to call the set size method. Why is that? Well, if there's validation, we can put it in this one place. And we don't have to put it everywhere that we set the size to the argument. So there's only one place in this class where the size gets set. Everything else calls that. By everything else, I mean this constructor calls that. And when we learn about exceptions and error catching and that kind of thing, we'll see the benefit of that. So that's not a rule about constructors, but that's a good practice. So I won't put it on the rule list. So if I call a constructor that accepts a certain number of arguments, that constructor can call another constructor on the same object, on the same class. And you often do that when you're defaulting things. This one defaults the crust to thin, this one defaults the crust or the pepperoni to false, and this one sets all three properties, either user specified or defaulted from one of these two constructors. Let me think for a minute. I think that's all the basic rules we have for constructors. Now, with subclasses, there's some additional rules. one last thing about this. If we call another constructor on same class, has to be the first command in the constructor. So going back to this, I couldn't have, I don't know, some other commands here and then have this call the argument at the bottom. I couldn't do that. I would have to make this the first line in the constructor, first line of code in the constructor. All right, maybe some more will come to me. I think that covers it pretty good though. Now in the subclass, and this is true if there's more, if a class is several layers deep. In other words, I can have a class that inherits from a class. That class can inherit from a class, and then that class can inherit. So I can have sort of like parent classes going up the chain. But anytime I call the constructor, when we call the constructor on a subclass, the constructor of parent class gets called first. So let's look at our example again. We have our order class. And we have our delivery order class. The delivery order class is a subclass of the order class. How do I know that? Because this says that delivery order extends order. So when I call this class, the constructor of the order class has to get called first. And you can see how we do that. We do that with a super call. Super in constructor calls superclasses constructor. It must be the first line of code in the constructor. So if we look at this, I couldn't have these things and then say super arg name, boom. In general, if we want to call a function on the super class, on the parent class, we say super in the name of the function. And if it's a constructor, we just say super. We can't have super and this in the same constructor. That makes sense because both the super and this have to be the first command in the class. Well, if you have two commands, they both can't be first in the class. If there is no super in the subclasses constructor, you still have to call a constructor, or there still will be a constructor called from the subclass. And that will be the no argument constructor will be called. So if you don't put super in your subclass's constructor, the Java virtual machine the Java runtime engine is going to run the no argument constructor of the superclass. Now, if it doesn't have one, you're going to get an error. Pardon me? It needs a default. Needs a default, needs something. I would never do this. Even if I wanted to call the no argument constructor on the superclass, I would say this, or I'm sorry, super. I would explicitly call it, because that's liable to be confusing if someone forgets the rules for constructor. So I think these cover the rules. Let's do some what ifs. Let's look at our order and delivery order example. Delivery order and order. We have a single one or two argument constructor on the order class. We have a single 6 argument function on the delivery order. When we call this, we want to create a delivery order, we have to supply all 6 of these arguments. There is not a function that only accepts 2 arguments on the delivery order. So if I'm going to call that within my order test, if I want a delivery order, I have to specify all 6 of those arguments. So what happens when I call that? First thing it's going to do is it's going to call the orders to argument constructor, set the name in the phone, and then these others get initialized. Now what's going to happen if I do this? Never mind, let's compile this first. So if I compile this, it compiles cleanly. What if I remove this line of code? Let's think about this for a minute. Make a prediction in your mind about what's going to happen. It's an order. Now, if you see this where it says actual and formal argument lists differ in length, that means that you don't have the arguments right on your constructor or other function. Now let's think about that. It's saying that there is no constructor for order in the class order that matches what is being called. Let's make sure we understand that. What constructor in order is being called? Well, we didn't specify one, but according to our rules, there's no super in the subclass's constructor, the no argument constructor will be called. The order does not have a no argument constructor, and therefore it's going to give me an error. Now, if I got rid of this constructor, it would actually work, but that wouldn't be a good idea because we would not be initializing those variables then. All right, let's look at, I added another class to this. In addition to the pizza, I have a stuffed crust pizza. Let's open that up, and those I have pretty much the same constructors I have in pizza, I have in the stuffed crust pizza. And they simply call the constructor on the superclass. That works because there's no additional information about a stuffed crust pizza that we need to give it to create it, like there is with the delivery order where we have to create the additional information of the person's address. Now, question, can we add a stuffed crust pizza to the array list for pizzas in the order? Notice this. Array list pizza is an array list containing pizzas. Our add function says take a pizza and add it to that array list. Can we do that with a stuffed crust pizza? And the answer is yes, we can. Why can we do that? Well, because a stuffed crust pizza is a pizza. It's a specialized form of a pizza. It's just a pizza with some additional characteristics in it that overrides for the price calculation. So therefore, in my test class, I can do this. I can create stuffed crust pizza, and I can add it to this delivery orders, and it will calculate it correct. What's more, when the order loops through and calculates the price of the pizza, it's going to call the function on the stuffed crust pizza for that particular pizza. Let me show you what I mean. I compiled it. Save it. Oh, I know what I did. I clicked save. I want to save all. There we go. Super back. Oh, you're absolutely right. Thank you. That was here. Yeah. Now, if I was a professor that didn't mind lying to his class, I'd have told you that I wanted you to catch that error, and I made the error on purpose, but I'm not going to say that because I did not make that error on purpose. My mistake is I thought I corrected it and just didn't save it. There we go. Now, if we run this, this delivery order, the cost of the order is $38. So how was that calculated? Well, what do we have on that order? We have pizza 3, 4, and the stuffed crust. Pizza 3 is a thick crust with no pepperoni. That is small thick crust with no pepperoni. So that is $8. Pizza 4 is a large. So the one argument constructor gets called in pizza. All right. And we default and call the 2 argument constructor, default and call the 3. So that by the end of all this, we get a large thin crust pizza with no pepperoni. So the cost of that is $12. So we're at $20 for this order. Now let's see the stuffed crust pizza. Stuffed crust pizza is small, thick crust. So it's going to call the super small 2 argument constructor. And the price of a stuffed crust pizza is going to be $12. So the total price should be $32, except I got $38. But I forgot the price of delivery. Oh, it's thick crust. And it doesn't have pepperoni. I think I made a mistake in my mental math. I think. It didn't. Yeah, so this we had 8, and that's, well, let's look. Small. Oh, in this version of it, I had an extra $1 for a thick crust pizza. My mistake. So this one's 9. This one's 12. That's 21. And it's $2 for delivery order, I think. $5 for delivery order. And yeah, and then the other one is $12, so that adds up to the $38. Now this brings up polymorphism, and polymorphism means that when we define an argument or when we define an object as being of a certain type, we can actually put other objects in there provided they inherit from that object. So I can add a stuffed crust pizza to the list of pizzas on the order object. Why is that? Well, because the stuffed crust pizza is a pizza. So it's not, it is a stuffed crust pizza, but it's also a pizza. So I can add it to the list. I can add it to that array list. Yet when it comes time to do the calculation, it's going to call the proper function, and it's going to call the stuffed crust pizzas function and not the pizzas function for calculating the cost. That's a nice little feature. The one thing we can't do is we cannot call a method that doesn't exist on the pizza if we declare it as a stuff. If we declare a object as a pizza, well, let me write the code to do this rather than speculating. Let's go here. I can say, let's change pizza 4. I can say pizza 4, stuffed crust pizza, large. I can say pizza and put in it a variable that is a subclass of pizza. That's allowable. And this is going to compile. And what's more, it will give us the right value for that. Large thick crust pizza is, according to the stuffed crust pizza function, is $20. So we can define it as a pizza, but when it's used, it will call the functions that are declared on the stuffed crust pizza class. Now, what I can't do is if there's a function that exists only on the stuffed crust pizza, I'm just going to put an empty function here. I am not allowed to say p4.empty function. Why not? Because empty function is not declared on the pizza. So to summarize this, it's a little confusing. What we declare the object reference as determines what functions we can call. We can call any of the functions that are valid for pizza. We cannot call any of the functions that are declared only in the stuffed crust pizza, even if we declare it equal to new stuffed crust pizza. The type of pointer limits what functions we can call. This, the class that we use when we create the new object, determines what version of the functions we're going to get. So we're going to get the versions of the functions that are declared on stuffed crust pizza. That is polymorphism. We can use stuffed crust pizza anywhere that we can use a pizza. Now, if I do this, I'm not going to get my compile error. Why? Because this side determines what functions you can call. I made it a stuffed crust pizza. Well, I can call that extra function on it. And I can also add it to an order, even though it's a stuffed crust pizza. because it is also a pizza, right? Can be a little hard to think of a object as being more than one class, but in everyday life, we do it all the time, right? You know, I am a person, I am a professor, and I am a parent, you know? We have no problem thinking in the real world in those terms. And the only difference in Java coding is there's only sort of one line of inheritance. So in this case, a stuffed crust pizza is a pizza. Now, maybe pizza could be a food product or something like that. In which case, stuffed crust pizza could be used anywhere that those are defined. All right, a couple more things I want to go over today, even if they're just pointing you to where they are. Class diagrams. Here is a thing of showing a class diagram. In almost every kind of programming, doing some sort of planning first before you actually start writing the code is good. And the class diagram is a way that you can define your classes and sketch them out before you actually start coding them. Really, once you design the classes, a lot of the work is done. So maybe a senior programmer would do this part, a junior programmer would do the actual implementation of those classes. Test cases. What is a test case? Now they kind of go overboard a little bit, but minimally, and I should require that you turn this in, but you document the test cases. What are you going to test? So in our case, scenario might be a out-of-county resident with 5 credit hours. All right, the test step, how are we going to run it? We're going to run our unit test because it's coded there. The expected result, I expect the tuition to be such and such. Out of county with 5 credits, I expect it to be 921. We run the unit test and look, is it 921 or not? And you need to test very thoroughly because, again, just testing 1 or 2 different tuition types and credit hours is not adequate to thoroughly test this. Now, a lot of people get confused with Java dates. I have information about how to use Java dates, and I've created a class here called Fun with Dates. That you can look at and run, and we'll tell you some functions that you can perform with dates. And it shows us about creating dates and running on those different test occurrences. So we could create a date that contains the current date. These are two different ways that I can create the 4th of July, 2016. But notice this if statement says that they're not equal. They're not equal because they're both object references and they point to different objects. So equal for object references mean do they point to the same object? If I use the equals function, however, it will tell me they're equal. I can add days. I can see if one date is after a date. I can get the difference in number of days. Days until, and so on. Spend some time reviewing this as well as the documentation I give in dates. A lot of students have difficulties with this. Take a shot at it and don't hesitate to ask because your next lab is going to include using dates. Are there any questions? All right, that's all I had for today. We'll either see you in lab or we'll see you next week.